hope it works now. Yep, no warning. Okay. I think we did the rectangle situation. Let me know if we didn't. Cylindrical tank, I don't remember if we did it or not. The ellipse, find dy over dt and dx over dt. The weight of an astronaut, okay. I think we did the particle moving along a hyperbola. I think we did this one, if I remember correctly. I think we did the plane flying horizontally. I don't remember if we did the snowball. Did we do the snowball? You want to do the snowball?
Yeah, we did a snowball.
Okay, so let's look at the snowball. Okay, if a snowball melts so that its surface area decreases at a rate of 1 centimeter squared per minute, and it decreases, okay? Find the rate at which the diameter decreases when the diameter is 10 centimeters. Good. What is given in the problem? What is this? And then what we are asked to find. So let's go back and read it again. Let me also plug my computer in just in case. Okay. Good. So if a snowball melts so that its surface area decreases at a rate of 1 centimeter squared per minute, what does this represent? So when it says decreases, I have to put minus. If it says increases, I leave it positive. So what is this? Just give it a shot. Let's look again. So what should I write?
Surface area?
So what do I write here?
Right.
When I see two measurement units, I cannot think. I have to have an answer immediately.
Is it dx over dt?
Correct. Very good. So ds over dt. When you see two measurement units, there is no situation in related rates. Of course, I can't think of maybe some things in some different field, but if I am given something like something is decreasing at a rate, it says rate, right? At a rate of such and such, and I see two measurement units, then I know that this has to be a derivative, and the top has to have something to do with this measurement unit, and the denominator has to have something to do with this measurement unit. Awesome. Allow me to change the diameter and denote it by W. That's a dangerous letter when it comes to differentiating and stuff. So I will not use D. Okay, so I use W. So now let's see what we are asked to find. Let's go back. What am I asked to find? I am asked to find the rate at which the diameter decreases when the diameter is 10. So I expect to get a negative number here, right? And what is it?
dw
Yes, dw
over dt.
over dt. dw over dt. Excellent. And I made myself a note that the answer should also be negative. Always remember, this is a trap. I can never plug in that number till the final step of the problem. Anything that follows after the word when or if or such and such, I can think of others right now, but every time I see when or knowing that blah, blah, blah is such and such, you know that that is a trap. Okay, where is my starting point? What do I have to start with? I'm not expecting the formula. I'm expecting just what am I, where do I start? Where is my first step? What do I think of? In my mind, what do I think of doing first or writing first?
You have to find the equation.
Yes, so I have to write the surface area. I know not too many people remember the surface area. You don't have to. On the side, a little calculation. We do have to remember that the volume of a sphere, because we're talking about a ball, is 4/3 pi r cubed. This we need to remember. The derivative of this is the surface area of the sphere. Very easy to remember. So the surface area of a sphere is just differentiate and you have 4 pi r squared for the sphere. So of course I don't need this, but I wanted to show you how I remember it. Very easy from differentiating the volume of a sphere. Once you differentiate, you simplify the 3 and you get this. So that's my starting point. So S equals 4 pi r squared. Notice that they don't say anything about r. They want us to talk in terms of W. No problem. W equals 2 times r. So then r equals W over 2. Very easy to show now that this is a function of W, which is 4 pi times W squared over 4. Simplify and I get S of W equals pi W squared. This is a function of time. This is a function of time. This is a function of time. In order not to confuse you, I'm just going to say that I don't write the W in there. S of W. So now I will differentiate both sides. This side is ds over dt. And maybe I shouldn't write it like this because it may be confusing, because this is a function of time, W is a function of time. Okay, so ds over dt equals pi to W and then dw over dt, because when I differentiate a function of a function, I bring down 2, I subtract 1 from the power, times the inner function prime. So this is what they're asking us to determine. I will solve first for dw over dt and then plug in the numbers. So dw over dt equals this piece over this piece. So ds over dt over 2 pi w. Only now, I will say, oh, ds over dt equals -1, and I'm given w equals 10. So then I have -1 over 2 pi times 10. And then, yes, I have to approximate this. And I put it in the calculator, of course. So I have, careful how you put it in. You have several options. I like this option because you know I'm in love with parentheses. Because if you don't put parentheses, then you have to be careful on how you enter it, times pi. Okay, I can show you if you don't put parentheses. So we get, of course, negative 0.0159. Before we do anything, and before I show you, let me show you the other one. So if you don't want to put parentheses, then you'll have to divide by 2. Then you have to divide by pi. Then you have to divide by 10. Or you can change it to 20. 1 divided by 20 and then divided by pi. That's also true. To get the correct answer, which I don't prefer. Why not write 1 over the denominator in parentheses? Because if you do not put the denominator in parentheses or write it like this, and you make the mistake to write this, of course you're never going to get the correct answer. This is completely different. What does the calculator do here? Divides 1 by 20, and the answer is multiplied by pi, which is not this, and it's not this. So be very careful, because this is a totally different story. Okay, so enough of that. I need the measurement unit. Of course, it's negative, because ds over dt is negative, so dw over dt will also be negative. But what is the measurement unit? And you have to give me 2 measurement units.
The centimeter per minute.
Perfect. Good, awesome. Then we want to look at definite and indefinite with the substitution rule. Any questions, anyone, on this? Okay, so that is the last section of the course. Oh, what am I doing? Okay, how do I get back to, where is my, where is my, how do I go back? Does it allow us to put in a page number or something or not? Oh, never mind. I bet it takes me to the same 3.7 or 9. I hope not. Okay, good. So okay, so we can choose anything we want from indefinite. Okay, we have indefinite from, whatever this is, where 9 through 54. So I'll go slowly, you pick. The integrals in Calc 2 are way more sophisticated. So that's the reason why I'm trying to show the simplest possible method with substitution, unless it's a more sophisticated problem and then you have to solve for dt or dy or du, whatever. But I'm trying to solve this to show the shortcut, the easiest way, because what you're facing in Calc 2 will be way more sophisticated. No comparison, really. I don't want to scare you or anything. Very doable, but way more sophisticated situations. Different rules, different substitutions, integration by parts, partial fraction decomposition, which is fun, real fun. Okay, we are looking at indefinite. Who would like to choose?
Can we do number 44?
Yes. Let's look at 44. 44, let me copy it. The integral from dt divided by cosine squared t and the square root of 1 plus tangent t. Again, on this problem, you can say, where do I start? It's a weird situation. Where is my starting point? Well, again, I inspect the function. Please inspect the function. Forget about dt. I'm looking at the function. The function is 1 over cosine squared, the square root of tangent t. And immediately when I looked at this, I said to myself, this is my problem. This is my problem. Because it's a square root of a plus b. No one can simplify this. Carved in stone, fixed. So if I can get rid of this, 1 over cosine squared can also be replaced by secant squared. Who knows? Maybe that's what I need. Of course that's what I need, because when I'm going to say u equals 1 plus tangent t du, can anyone give us du here?
Secant square dt.
Excellent. So the whole thing, excellent, thank you, Victoria. So this is the integral from, basically, I'm going to write it again. 1 over cosine squared is secant squared dt divided by the square root of 1 plus tangent t. I have not used the substitution yet. I just want you to see that this changed into this. And now this is a piece of cake. It became a piece of cake by inspection and realizing that 1 over cosine squared is this. Realizing that when I substitute, use any letter you want. You don't have to use u. Use anything else but t. Of course, you cannot use t. When I substitute, or I replace, in other words, or I name, or I let 1 plus tangent t be u, du equals secant squared dt, so this is exactly what I need. So this whole integral becomes du at the top. I don't even have to fudge a little number, divided by the square root of u. And this is the integral from u to negative 1/2 du. Why I need this? Because I don't know what I'm going to get, but if I change it into a power, this is easy now. Negative 1/2 plus 1, so it's u to 1/2 over 1/2 plus a constant c. So if it's an indefinite integral, please never forget the constant. Yes, I will flip to, I will have the square root, but it's an indefinite integral. I have to give the answer in the variable, in the original variable. So always, before you do anything, inspect, simplify, factor, whatever. So look at this and say, oh, okay, this is my problem. If I use this, then du is secant squared dt, but how do I get the secant squared? Because again, if I have 1/4, I can deal with it. But how can I deal with secant squared? I can make that up, but it's already there, hidden. By inspection, I realized that 1 over cosine squared is secant squared, and that's exactly what I needed. I changed the function into an equivalent function. I didn't change the function, I just presented it differently. And now I know that this is my du, and this is the square root of u. And then I take it from here. Very good pick. It was a very good pick. Thank you. Okay, anything else from indefinite?